Find the indicative derivative of y with respect to x for y equal to x to the power 5. So on this example, our goal is to find the derivative of y with respect to x for this function y equal to x to the power 5. So how can we find the derivative of this? We can use, it looks like the given function is actually like a power function, so we can use this formula which is known as power rule. So if we have x to the power n, then the derivative can be figured out by bring the power down, which is n, right? So write down the x as it is, subtract the power by 1. So this is known as power rule, and this is the formula we can apply here to find the derivative of y with respect to x. So if you want to apply the power rule, so what can we do? We can check in the power, so which is 5 here, so bring that down, right? Then whatever on the base, so this is x, so we can just write that base over here. So 5 times x to the power. Now we need to subtract the power by 1, so 5 minus 1. So this is equal to then 5 times x to the power 4, and this is the derivative of the given function with respect to x. Find derivative of y with respect to x for y equal to 1 over x to the power 8. So in this example, we have given that y equal to 1 over x to the power 8 is a function. Our goal is to find the derivative of this with respect to x. The given function 1 over x to the power 8 can be rewritten as x to the power negative 8. So by changing the positive exponent into the negative exponent, this is how we can write down. What is the benefit of this? Well, when we change into this form, then this resembles like x to the power n. So if that is the case, then we can use the power rule, which is find the power rule is, if we have x to the power n, then bring the power down, write down the x as it is, subtract the power by 1. That is how we can find the derivative. So if that is the case, you can clearly see here to find the derivative of x to the power minus 8. Now we can bring the power down, write down x as it is, subtract the power by 1. So negative 8 minus 1, right, will be there in the power. So this is equal to negative 8 times x to the power minus 9. This is the derivative of the given function. But if you want to write down this into the positive exponent, then we can write down this as negative 8 divided by x to the power 9. And this is the derivative of the given function. To find the derivative of x to the power 7 divided by 21, you can clearly see here this one is x to the power 71 is the given function. This can be also actually rewritten as 1 over 21 times x to the power 7. When you do that, you can clearly see there is a constant multiplied by x to the power 7. So if that is the case, we can actually use the constant multiple rule, which is if you have a constant multiply by a function, then the derivative will be write down the constant as it is, multiply by the derivative of the function f. So this is what the constant multiple rule. So if you want to use this rule, then we can clearly see the derivative of x to the power 7 over 21 will be that can be done by first rewriting x to the power 7 over 21, which is 1 over 21 times x to the power 7, right? And then 1 over 21 by the constant rule, we can take that out, multiply by derivative of x to the power 7. And the derivative of x to the power 7 by using the power rule, we can figure out as bring the power down, right? So derivative of x to the power 7 is bring the power down, write down the x as it is, subtract the power by 1. So 7 minus 1 will be 6. So this is the derivative of x to the power 7. And we can simplify the 1 over 21 times 7 means 7 over 21, which is if you simplify, this will be 1 over 3 times x to the power 6. Then if that is the case, x to the power 6 divided by 3 is the derivative of x to the power 7 over 21. Find the derivative of 8 times x to the power minus 7 minus 5 times x to the power minus 1 with respect to x. So we have given this function whose derivative we need to figure out with respect to x. So how can we do that? We can see here there are difference between two function, which is one is 8 times x to the power minus 7, another function is 5 times x to the power minus 1, and there is a difference between that. So if that is the case, then we can use the difference law. What the difference law what the difference law says, it says that to find the derivative of difference of the function like this, we can first find the derivative of 8 times x to the power minus 7. Okay, so find the derivative of the first term. Find the derivative of, let's say, another function which is 5 times x to the power minus 1, and if there is a difference between that, just find the difference of the derivative. So this is known as difference rule. So now when we do that, now let's try to find the derivative of the individual term. The derivative of the 8 times x to the power minus 7 is, by using the constant multiple rule, we can take the 8 out, and by using the power rule to find the derivative of x to the power minus 7, we can bring the power down, right, which is power rule. So bring the power down, write down x as it is, subtract the power by 1, so negative 7 minus 1 will be negative 8. Okay, so this is the derivative of 8 times x to the power minus 7. Similarly, the derivative of 5 times x to the power minus 1 will be, write down 5 as it is, right, and the derivative of x to the power minus 1 is, by using the power rule, negative 1 times x to the power negative 1 minus 1 will be negative 2. So this is the derivative of the given function. We can rewrite this as 8 times negative 7 will be negative 56, so negative 56 times x to the power minus 8, and then negative 5 times negative 1 will be, negative 5 times negative 1 will be positive 5 times x to the power minus 2, right? Or if you want to also write down on another alternative by changing the negative exponent into the positive exponent, this can be written as negative 56 over x to the power 8 plus 5 over x square is the derivative of 8 times x to the power minus 7 minus 5 times x to the power negative 1. Find the derivative of 9 times u to the power 0.2 minus 7 times u to the power 3.7. So you can see here on this given function we have a difference of two functions, which is 9 times u to the power minus u to the power 0.2 minus 7 times u to the power 3.7. So to find the derivative of these, we can use the difference rule, which says that let's just find the derivative of 9 times u to the power 0.2 with respect to u. Find the derivative of 7 times u to the power 3.7. So find the derivative of each of those terms, and then with respect to u, and then just find the difference between the derivatives. So that is what the difference law says. So now to find the derivative of 9 times u to the power 0.2, we can just use the constant multiple rule, which is bring the constant front, right, and then multiply by the derivative of u to the power 0.2, and derivative of u to the power 0.2 will be, by using the power rule, this will be 0.2 down, u is as it is, subtract the power by 1, so 0.2 minus 1. So this is the derivative of 9 times u to the power 0.2. In the similar way, we can find the derivative of 7 times u to the power 3.7 as 7 times 3.7, right? So derivative of u to the power 3.7 will be 3.7 times u to the power 3.7 minus 1 by using the power rule, right? So this is what we have. Now our job, this is the derivative of the given function, but if we want to simplify this further, then the derivative will be 9 times 0.2 will be 1.8, right, times u to the power 0.2 minus 1 will be negative 0.8, right, and then minus 7 times 3.7 will be 25.9, right? And u to the power 3.7 minus 1 will be 2.7. So this is the derivative of the given function. If you want to change it in everything into the positive exponent, this can be written as 1.8 over u to the power 0.8 minus 25.9 times u to the power 2.7. And this is the derivative of the given function. Find the derivative of 7x square over 6 minus 4 over 5x square. So this is the function we have given. Our goal is to find the derivative of that. So let's try to rewrite this function as, the first term can be rewritten as 7 over 6 times x square. I just want to separate the coefficient or the constant with the function. So 7 over 6 times x square minus the second term can be written as 4 over 5 times 1 over x square. But still you can further rewrite this as 7 over 6 x square minus 4 over 5 x to the power minus 2. What is the benefit of writing in this way? Well, now the basic differentiation rule that we have learned, we can actually directly apply when we rewrite into this form. You can see here, this is now, of course, like we have discussed earlier, we have a difference between two functions, so we can just use the difference law here, right? So the difference law says that find the derivative term by term. So in that case, we can find the derivative of 7 over 6 x square, right? And then we can also find the derivative of 4 over 5 x to the power minus 2, and whatever comes up, we just find the difference between these two derivative. So what is the derivative of 7 over 6 x square? By using the constant multiple rule, the derivative is bring the coefficient as it is times derivative of x square with respect to x will be just 2x, right? By using the power rule, minus in the same way 4 over 5 as it is times derivative of x to the power minus 2 will be, by using the power rule, bring the power down, which is negative 2, write down x as it is, subtract the power by 1, so negative 2 minus 1 will be negative 3. So this is the derivative of the given function. If you want to rewrite this, then this can be written as 7 over 6 times 2. If you simplify, this can be written as 7 over 3x. And then when you simplify, let's say 4 over 5, negative 4 over 5 times negative 2 will be positive 8 over 5 times x to the power minus 3. So this is the derivative. Or if you want to also write down on another alternative, this can be written as 7 over 3 times x plus 8 over 5 times x cubed, if you want to change the negative exponent into the positive exponent. So this is the derivative of the given function. Find the derivative of 2 over 7 times w to the power 5 plus 8 times cube root of w with respect to w. Let me rewrite this problem first. So we have given to differentiate 2 over 7 times w to the power 5. So that can be rewritten as 2 over 7 times 1 over w to the power 5. In the same way, the second term can be also rewritten as 8 times cube root of w, that can be changed into w to the power 1/3. I want to change into the exponent form because in that way we can use the power rule. Otherwise, to directly deal with the radical, we then have the basic differentiation rule, right? So that's why I want to change that into the exponent form. So let's do that, and then I can little bit rewrite this as 2 over 7 times 1 over w to the power 5 can be written as w to the power minus 5. If you want to change it into the negative exponent, plus 8 times w to the power 1/3. Why am I writing down into this form? You can clearly see, if I write down in this way, I can use the sum rule to find the derivative of the sum of these two functions, and at the same time w to the power minus 5 and w to the power 1 over 3, both of them can be, that their derivative can be figured out by using the power rule. So why don't we let's apply that. All right, so this is now our problem, right? So let's try to work on this. So let's first find the derivative of the first term, right? So the derivative of 2 to the power, let's try to find the derivative of the first term, which is we need to find the derivative of 2 over 7 times w to the power minus 5, plus we need to find the derivative of 8 times w to the power 1/3. And the derivative of the first term can be figured out by using the constant multiple rule. We can take the constant 2 over 7 out, right, times, and just find the derivative of w to the power minus 5 by using the power rule. That will be negative 5 times w to the power negative 5 minus 1, right? In the same way, we can find the derivative of 8 times w to the power 1/3, as it is a constant, right? Write down as it is, times the derivative of w to the power 1/3 will be 1/3 as it is, and then w to the power 1/3 minus 1, right? So by using the power rule. All right, so this is the derivative, but if you want to simplify and then rewrite, this can be written as negative 5 over 7 times w to the power negative 5 minus 1 will be negative 6, plus 8 over 3 times w to the power 1 over 3 minus 1 will be, what will be that? Negative 2/3. So this would be the simplification of the given, the derivative of the given function. So this is already the derivative, but still if you want to rewrite this into the positive exponent form, then this can be written as negative 5 over 7 times w to the power 6 plus 8 over 3 to the power 3 times w to the power 2/3. Or if you still want to change this into, for example, the second term actually can be changed, this one can be changed into the exponent form. So this can be written as 8 over 3 times cube root of w square. So this is already the derivative of the function. If you want to rewrite into this form or in the positive exponent form, or also want to change the exponent into the radical form, we have couple of alternatives. So that is the derivative of 2 over 7 times w to the power 5 plus 8 times cube root of w. So this is the required derivative. Find y prime if y is given like this, which is x to the power 6 minus 5x to the power 5 plus 4, and everything on the numerator divided by x to the power 4. So how to find the derivative of this? So to just use the basic differentiation rule, I can see here the given function, which is y equal to x to the power 6 minus 5x to the power 5 plus 4 divided by x to the power 4. So what I can do here is each term on the denominator, I can actually just divide by the denominator. So I can divide x to the power 6 by x to the power 4. 5x to the power 5 I can divide by x to the power 4, and the last term 4, that can be also divided by x to the power 4. So I can rewrite like this way. So when I rewrite in this way, I can simplify the first term, where I have x to the power 6 at the top, x to the power 4 at the bottom. So both of them has the x as a common base. So if that is the case, I can use the exponent law, and then I can write down this as x to the power 6 minus 4. This is from the exponent law, right? So what is the exponent law? If you have x to the power a divided by x to the power b, if they have the same base, then that can be combined as x to the power a minus b. So that's what the law I have used. Similarly, on the second term, I can write down this. The second term can be written as 5 is a constant, write down as it is, and x to the power 5, x to the power 4 have the same base. So by again using the same exponent law, this can be written as 5 minus 4. And the last term can be written as, by either you can use the same law, or you can say by using the changing the positive exponent into the negative exponent, this can be written as 4 times x to the power minus 4. So the given problem now can be rewritten as x to the power 6 minus 4 is 2, so x square minus 5 times x to the power 5 minus 4 is 1, so just 5 times x plus 4 times x to the power minus 4. So far I have just rewrite the given problem. So now I can actually, or some of you may have noticed, I can just use the basic differentiation rule. So let's apply that to find the derivative of this. Alright, so what is the derivative? What is y prime? Derivative of x square with respect to x by using the power rule, that will be 2x, right? And then minus, what is the derivative of 5x? The derivative of 5x with respect to x will be 5 times derivative of x with respect to x will be just 1, so 5 times 1 will be 5 plus 4 times x to the power minus 4. How to find the derivative of that? The derivative of that will be, because of the constant multiple rule, 4 is as it is, derivative of x to the power minus 4 will be by using the power rule, negative what is that, bring the power down, right? So negative 4 is down, write down the x as it is, subtract the power by 1, so negative 4 minus 1 will be negative 5, and this is the y prime, or the derivative of y with respect to x. If you want to rewrite this in some other alternative form, this can be written as 2x minus 5 minus 16 times x to the power minus 5. If you don't like the negative exponent, you can still change that into the positive exponent as negative 16 over x to the power 5. Or if you exactly want to write down how the problem was given, that means something on the numerator, something on the denominator, then you can write down the lowest common denominator, find the lowest common denominator, which is x to the power 5. Then on the numerator we'll have 2 times x to the power 6 minus 5 times x to the power 5 minus 16 is the derivative of y with respect to x, or you can say just y prime, whatever notation you use. This is the derivative of the given function x to the power 6 minus 5x to the power 5 plus 4 divided by x to the power 4.